weak bus or the affected feeders to implement the voltage and reactive power compensation technique for the selected distribution substations or selected bus or networks. So, significance of this study: enhancing reactive power compensation and the voltage drop enhancement in solar substation, 50 kV outgoing feeder. Effect on minimizing power loss as well as a possible advantage of incorporating this technology into the solar substation in 50 kV. Improving distribution network performance and guaranteeing the consistent supply of power to consume through case state and simulate tests. So also we have literature review and theoretical backgrounds. So our literature review and theoretical background contain two parts or distribution network arrangement parts. That Ethiopia, two different type of distribution system. These are radial and radial switching distribution systems. Radial, which means each user radially has a single supply source, and also there is a breaking in the system like a tree. Switching distribution systems that have number of parallel sources of supply. So there are so many supply which are distribution systems. So reactive power and the voltage drop in the distribution systems. Power system consists of a generation, transmission, and distribution component with a distribution experience or a voltage drop issue due to overloading and the load unbalance. Various solutions to reactive power and the voltage drop problem have been explored, including distribution generation, pack device, and the load synchronization and the load sharing development. So reactive power compensation through efficiency of use to compensation tool and machinery can lower the grid operation energy, improve power factor, and enhance the voltage quality. So reactive power enhancement used to this. And a distributed generation can be used to reduce active power by increasing active power, improving voltage regulation, and reducing loss. So also flexible alternating current distribution system or FACTS is a various reactive power compensation like device like CVC, Staticom, UFS used to manage reactive power and voltage. So shunt capacitors also shunt banks are inexpensively space inefficient and can be switched or constantly impact voltage regulation. Or also one of is shunt capacitor is one of a factors. And also passive and active device works together to maintain a desired voltage across systems. Mechanically switching to shunt caps at a substation provide active power and improve voltage. So these are the gap in the summary of the statements. So we use to do our thesis. We combine these four main studies. These are already their studies. Their gap are we select or we detail do this. So also the main part of our study is methodology. On a methodology, these are a distribution system data analysis and the modeling on here. So the incoming feeder line of a pseudo substation or pseudo one substation and additional source provides the distribution system minimization data used in this investigation. So we use so many data based on substation data also and the investigated data only or measured data only. So the information is also gathered by closely observing the substation and the distribution line, allowing the distribution line out, including loading of feeder and the transformers. There is the load of the feeder and the transformer can be detailedly required or data collection analysis on here. Data are evaluated to determine this distribution substation current, reactive power, and the bus voltage stats, as well as to pinpoint the primary issues. Also, line data, bus data transfer rating, loads, and the bus voltage information are required for reactive power compensation and the bus voltage analysis. Both quantitative and qualitative data analysis of the accurate data are performed using a matter of softwares. So a case study and the basic data on here. So our case study area is the pseudo substation, pseudo one substations. There are 8 outgoing feeders and 1 entering feeder at pseudo substation. So so from the grid or 400 kV grids or from Addis Ababa that download or that 400 kV or the mine grids that are on Addis Then from MADIS to our substation by 132 kV income feeder to as a solar substation, which is fed by main grid by interconnect system. So a main grid 400 kV to wide grid step down to 130 kV kilowatt solar kV volt that has income to solar substation by interconnected systems that are ISC as Ethiopia standard. Most of them are connected or interconnected systems. Also, totally there are four 50 kV 50 kV feeders, 333 kV and 166 kV feeder that are sent out from the Sodo 1 substations. So 33 kV feeders are Abala feeder, the Desa feeder, and the Sorto feeder. 66 kV that are sent out from feeder by two Gibe 3 feeders. 50 kV feeders are Sodo, Laita Sodo town, Boditi feeder, Araka feeder, and the Plate feeders. So 63, 33, and 66 and 66, 33 and 50 kV network are run as radially connected, and they are 136, 33 to 66, 132 to 33, and 132 to 50 kV transformers are respectively totally capacity of 66 kV are 160 megavolt ampere, 33 kV are 25 megavolt ampere, and 50 kV are 20 mega ampere. So solar substation has totally the load of 17.9 megawatt as active power and 14.74 megavolt amperes, megavolt bars. So these are active power. So generally 50 kV feeders have combined load of that are 4 feeders combine the active power of 13.9 megawatt and 10.36 as an active power. So the voltage composition of this distribution substation and the two systems are this one. These are the voltage composition or diagrams. These are a single line diagram which are designed by Matla by power. So the peak and the maximum, the minimum load of our each outgoing feeders are listed as well. Sodo, later Sodo's feeder are 8.4 megawatt, Boditi 3.5 megawatt, Araka 1.5, Blate 0.5, Sorto, Bale Sorto 1.5, Abela 1.9, Pedesa 1.3, and Gibe 3 1.2. So these are a breaking current, or these are the breakers. There's the breaking currents. So these are the minimum load for each feeders. So the comparison is the average load, peak load, and the minimum load for real power or mega active, and the current of each feeder are in the system are graphically represented in this. So when a Sodo feeder has highest peak load are 8.4 megawatt compared to each other feeder, and the Plate feeder has lowest peak load has 0.5. So the lowest peak load are 0.5. So Sodo feeder has a highest peak load, it more affect to distribution substation system bus line and transfer status. So these are data for each outgoing feeders. So also to do to select or to plan to improve our reactive power and the voltage regulation. First of all, we know the voltage stability index on each feeders. So those voltage indexes try to the stability or the system stability of the voltage to each feeder. So yeah, it's voltage stability is a tool for accessing whether the system voltage is stable or not, and how close the system is to instability. So this voltage stability used to select or to select the bus or the pillars which feeder is voltage stability stable or not. So based on this voltage stability data, we select the bus or weak bus, and we composite that bus to we compensate that bus, that bus and connect which are FCTs or we FCTCR on there. So voltage stability index provide valuable information to the system planner and the operator about the condition of voltage stability in the system. So voltage stability in the system, which can provide the information to the planner or operator which are work on the substation to take the action about the feeders are going, the feeders voltage are going to the conditions or to the plan power outage. So the means of stability, they can take the action before the happening of a planned outage, power outage. So it identifies the critical bus in the power system. So this voltage stability also identify the critical bus in the power system and determines the stability condition of each line connected between two buses in an interconnected network system. So generally, this voltage stability index is to determine the system proximity to the coal bus, establish when the voltage unstable could occur, and identify the weak bus in the area which is involved, or identify the weak bus in the area involved that the voltage drop, either instability of the system. So we identify this voltage stability index identify such to us. The second one is also these line stability indexes are the much useful thing to us, to our thesis, is to evaluate the stability of the line between two buses in an interconnected system reduced to the single. So this evaluates, we take two buses, bus 1 and bus 2, and it evaluates the stability of the line by measuring the line data, considering the factors such as impedance, voltage, and the power flow. So we're using this concept of power flow in the line and analyze the one model representation for the power flow at the receiving end of this power system like this. So these are line stability index. These are our mathematical model. The power flow distribution line for two bus system is used, and the discriminant of the voltage quadratic equation. These are mathematically. Finally I generalize and I take this on final quadratic equation. That means it has input or it has done by quadratic equation system. So on here, the power flow through distribution line of for two bus system is used, and the discriminant of the voltage quadratic equation is said to be greater than or equal to 0. That means in quadratic equation we know b square is equals to under radical at on here we say lmn or square or lmn square is equals to that b square minus 4 under radical b square is equal minus b plus or minus under radical b square minus 4ac at the quadratic equation. So at this value, at the quadratic equation value, every time greater than 0 of 0, the line stability index is obtained. If this is less than 0, the root will be imaginary. That means instability can be occur. So these are a quadratic equation. If the discriminant is less than or 0, the root will be imaginary, such as imaginary, which means the under radical value or under radical value, if the value is a negative value, so it directly take the negative value, this value on b square sine radical theta minus alpha z square minus 4a sine this value is on the radical. If it's negative, the system will be instability. So the line index is also directly related to the reactive power and indirectly related to the active power through the voltage phase angle. So these are a line and a load data of pseudo distribution substations. It's a line data is from line to line to 1 to line 2. These are a substation, one line, one substation data, or a slack bus. The bus from this bus to these are the data. These are which we are measured or we are taken from the substation. So these are data calculated line stability data that are calculated for each bus from bus line to. So generally, this line stability, generally the line stability index measures the data from two bus 1 and bus 2. If the line data bus 1 to bus 2 are calculated, their value is approximately or close to 1, that line or that feeder is very instability, or that line or that feeder is instable in the system. So we select that feeder as instability feeder or inter bus. So this instability, this value or that feeder can take intend to composite or. So a line in the system said to be close to instability when line instability index is close to 1. So the line is said to be close to instability when the line instability index is close to 1. That means on this graph, on this table, this table shows the line index, the line stability indexes. So based on this line, the line is said to be close to instability when element is close to 1. The line stability index element or line stability index of line 2 or connected to bus 2 to 3 is 0.714. So where these are calculated on the above the table. So instead of this, bus 2 is identified as the weakest load bus in the system with a maximum permissible reactive power load of 6.29 MVR and a critical voltage of 0.9. So these are this data 0.714 is the element, but this is a calculated data. We take the data from this. So this data. So we use this line to data and I calculate on here. We get 0.7414. So it intended to the bus to us a weak load bus. So any increasing in the reactive power load at the bus 2 is likely to result in voltage call pass or instability or happen. So bus 2 is considered as an optimal location for a compensating device to enhance the stabilities. Among the line in the system, line 1 and line 9 and the connecting bus 7 to 10, bus 10 is the most stable with a lowest line stability index value of 0.1377. That means this one, this line 9, this one. So these are calculated by the use of formula. This formula use of this formula element value. So we calculate like this. These are the line stability index of solar substation lines. These are graphically presented by use of the above graph. So another useful thing to our thesis or our research, our investigation is voltage constraints. So this voltage constraint is mostly used for voltage minimum and the maximum peak of the substation. So on ideally or voltage over times plus or minus 5%. That means if the voltage included on the constant of voltage is plus or minus %. So our constant is 0.95 per unit up to 1.05 per unit. So a bus that are out of this ranges, this will be if it is less than 0.9 or it is greater than 1.05 per unit. These lines are unstable and bus feeders are unstable.
And let me share my slides. Okay, let me start with as usual, like the editing issue. Most of the editing actually I will send. I will concentrate more on questions, but the most important thing I will not miss that one. So the first thing, like your title is too long. too long, and there is a room actually to just rectify it. If you count like the number of words, like more than 17, something like that. So there is a rule, and based on that rule, you can modify. And one of the method how to modify is like you can say like voltage profile improvement and reactive power compensation for power loss minimization of distribution networks. Then in the bracket case study, Walaita Sodo substation, then this FCTCR case can be integrated in the objective case or in the methodology section or whatever. So by using FCTCR, if you minimize that one, I think you can minimize also the length of the title. So that is the case. Other questions actually later I will ask you based on the title. Now on theoretical notes and the literature review, something like you have to like 2.1, 2.2, something like you can divide into theoretical part and the literature review part, because this is almost, it looks like a theory and it is a kind of just complicated. So you have to just change that arrangement. And the acronym part, I think this one, facts controller. So the definition is wrong. So just correct this one. Let me come to the most important part on the abstract part. So in your abstract, you used fixed capacitor thyristor control reactor. Why? Among the facts controller, you used this one because abstract should be clearly written. Like when you write the introductory part of the abstract, so you have to show us why you chose this method. So that is missing, so you have to rewrite it. And the other, you said that the simulation results clearly demonstrate the effectiveness of this one. How effective? Any comparison with other methods, so that is also missing. And here it is suggested to explore the potential benefit of implementing a static VAR compensator as an alternative fact devices you mentioned. And furthermore, the optimization of factors you said. So more emphasis given on the theoretical issue. And because like the abstract, mostly you have to clearly specify your methods, approaches, your results. But most of the things that are written here are theories related to fact. So more information is given and you have to rewrite it. The other most important part here is, like you mentioned, the result indicates significant improvement in the voltage profile with the bus voltage magnitude as the weak bus decreasing from 1.44 to 0.97. What is the main objective of your work, basically? Is the problem of over voltage or under voltage in this area, in the study area? So take this as an example, because the result in your result section, you may look different things. Here, something over voltage is there and correction mechanism is there. So on the result section that is mentioned. And the other, yeah, here more of theory. Like, so you have to just minimize those theoretical parts so that concentrate more on your introductory or methodology, and mostly better to write more on the result section, the result of your own, rather than writing the theory aspects of the advantage of FCTCR. The other, you mentioned about the efficiency. I could find the efficiency aspect in your work. So how efficient and where is the benchmark? And the other, since your abstract is too long, you didn't get space, so no keywords also here. So you just missed the keyword. So just add that one. On the statement of the problem, you mentioned that the problem addressed in this study is to investigate the potential of utilization. So why you specifically used FCTCR based on your assessment in your abstract. So actually, I just mentioned this one earlier. So you respond it later together with all the gap. The research gap is the most important part of your work, and identifying that actually lead us to read your method and know your results. And the first one, it is not clearly actually specified or written the way actually you assessed your literatures and the way you summarized have some gap. For instance, it has been suggested that the backward-forward sweep algorithm and the fixed capacitor thyristor controlled be used to identify weak buses and make adjustment for them. Who actually suggested? You suggested or researchers suggested? And how it become a gap here? If already suggested, that is not the gap, because already suggested there, already identified. So in your case, if you say the gap or the summary of the literature gap means you are identifying it or suggesting it. So one of the question is whether you suggested it or already suggested. And if already suggested, what is your contribution here? And the other, limited attention is paid to asymmetric distribution network, as you mentioned. And we expect something related to this one, result related to symmetric type, like limited attention is paid to asymmetric distribution network, as you said. So symmetric networks have been the main focus. So we will see, we will expect from your result. The other, you mentioned the development of algorithms specifically suited for asymmetric distribution network is an area lacking in the research. And what is your take in this? So later you just summarize for us. And the cost effectiveness issue is mentioned. We didn't see those issues in your result. And if that is the case, you have to mention in the abstract also. The power factor, the voltage stability, and everything. The development of algorithms. And if this is actually specified in the gap, actually we expect from your result. There is a deficiency of research in this field and in the development algorithms that can manage the intricacies of the distribution generation integration. FCTCR effectiveness in the active power compensation increased the stability of the stability of voltage. So all these things, is this a theory or you are expected to do or bridge the gap of all those mentioned here? So these are the things that are lacking in your assessment. The other, peak and the minimum load voltage load of 3 months of each feeder is just measured or actually recorded, you mentioned. 3 months, peak and the minimum. Walaita Sodo, Boditi, Araka, Bilate, and this is a time. Here, different time, like 19, 20, and these 3 months. Is that average, or I don't know how actually the data is selected. Here, it's 3 months of each feeder, but its time is mentioned here. So you have to respond on this one. The other, figure 3.3 shows Walaita Sodo feeder has the highest peak load of 8.4. Is this figure 3.3 or figure 3.4? 3.3 is something different. Figure 3.3 is something different. And again, in different places, actually, research methodology. Actually, what is a methodology? This is actually workflow, something related to workflow, not a methodology is a method or the technique, the approach that you use. This is the flow, it looks like that. The other, this section, line stability index. Which reference that you use? Asagid.
Habit.
This is the most important. Which references you use for this one? It's a base. This is a base reference for your work, right?
Yeah.
Which reference you used? This is 26? 26?
Yeah, load lines stability እንትን ለማለት ከኋላ እንትን ላይ አለ reference በአፔንዲክስ ላይ ተቀምጦ
Okay, let me take you to that point. 40 this is 26, right? 26 means this one, right? First of all, I don't know how it is written, because a new voltage stability index for predict voltage collapse in electric power system networks, then something is written repeatedly, and whether it is Turkish or English, we don't know exactly. I was searching, I couldn't find. However, your reference is this. You know Isaac?
Isaac.
Huh? Let me. Just tell me, did you use this one, this work for your thesis? A new voltage stability index for predicting voltage collapse in electrical power system networks? አሰግድ
አቤት
ተጠቅመሃል ይሄን?
አልተጠቀምኩም።
Actually, there is no problem to use a reference, because research is always incremental. The problem is whether you acknowledge the work of others or not. That is the problem I just find here. Actually, most of the equations are taken from this, but you didn't acknowledge. And you did a mistake also. And what is this? Just respond to this question. Like, do you think that these equations are correct?
Yes.
They are correct?
Yes.
Okay, explain to us. 3 to 1.
ላይን ስታቢሊቲ ግን ብዙም አይታይም።
ይታያል አይደል?
ብዙም አይታይም።
እሺ, let me this is the equation on 3 to 1.
The line stability index is not minus, is equals to 4 times impedance of the transformer or the feeder times reactive pole.
ስለዚህ ችግር የለም 3 2 1 ላይ actually yeah, the problem is በትክክል ስላልተጠቀምከው ነው እንጂ በደንብ እዚህ ጋር የተቀመጠ አፕሮች አለ። ያንን አፕሮች በትክክል አልተጠቀምከው እና አክኖሌጅም አላደረክም፣ በትክክልም አልተጠቀምከውም። so that is your problem and that is wrong። እንግዲህ ያንን ተጠቅመ ሲሙሌት አድርገ ከሆነ እና ሪዛልት አግኝተ ከሆነ እንትን ያደርጋል እና ያው እያንዳንዱ እዚህ ላይ ያለ ማቴሪያል ነው። acknowledge አላደረክም። that is the problem and let us turn back. ስለዚህ ይሄ ሮንግ ነው። ይሄ ትክክል አይደለም፣ መስተካከል አለበት። ከዛ በተረፈ ይሄ ምንድነው? ይሄ what is this? Is overlapping on something or this figure is
ፊገር ወደ ላይ ሄደው ነው አጋጣሚ ሲላክ ፊደል ሲቀየር ስተት ነው።
Okay, so this is actually needs some correction. And modeled SVC rating cost like 11.54 megavar, right?
Yeah.
11.54 cost per kvar is like this, and total cost in US dollar, right?
Yeah.
Is that feasible? Because you mentioned about the cost issues and so on.
Yes.
Is that feasible? Can you convince Ethiopian Electric Power or Ethiopian Electric Utility, cost benefit analysis and everything? Actually, you have to just include. Yeah, some correction. That's an editing issue. I will not raise. The other reduction of power loss somewhere. I read something which is completely irrelevant to your work. Like you mentioned here, comparison between techniques. The following comparisons are made using the result of simulation and numerical analysis of the costs. And somewhere here, use of micro turbine. And here, how actually, why you brought this one? And from where it came, like suddenly pop up, suddenly. And why it is included here? Okay, just later you can respond because it's irrelevant and I know correlation with the previous works like capacitor. Okay, you are talking about SVC, but here something different is actually popping up, and I don't know how. Just and result section, even the BSC in the BSC level, you cannot actually represent your result like this. The black and the white. No description of the x-axis, the y-axis, and you have to just change everything. And again here, figure 4.4 below depicts the reactive power supplied by a source. And everything up to this point, some correction is required. And figure 4.9. Here I see comparison of bus voltage without FCTCR with FCTCR. But here, you said that without FCTCR, weak bus 2 with FCTCR. Which one is which from this figure? Here, 3 description, right?
Yeah.
Here, I see 2 figures.
Yes.
Which one is which?
Red line is without also FCR. That is 2. Also, there is a point.
No, see, 3 scenarios are here.
Yes.
Okay, just some correction is there actually. A new recommendation. In light of the research conducted on reactive power compensation and loss minimization at Walaita Sodo substation, using this method, the following recommendations are provided. Recommendation for FACTS devices. It is recommended to explore the potential benefit of implementing a static VAR compensator at Walaita. Is this a kind of recommendation that you have to give or based on your work?
Based on my work.
You have your method, right?
Yeah.
You have your method, and FCTCR is.
አይ በሱ የኤፍሲቲአሩ በዛ ልክ እንትላልና ሶ ሌላዎቹ ዊክ ባሱ እንዴት ሰጀስት አንተ አድርገህ ነው ወይስ ከተደረገ ነው የሚለው ቤዝድ ኦን በዚ ዳታ በራሴ ነው እንትን ያልኩት ኤፒስቲአር ለምን ብልተጠቀምኩ የሚል የተነሳ ጥያቄ አለ። ኤፒስቲአሩ ካሉት ከአሁን እንትኖች የተሻለ ቴስ ያላቸውና እንደው ቶሎ ሪስፖንስ ስለሚያደርግ ለተሰጠው እንትን ምላሹን ቶሎ ፈጠን ባለ ሪስፖንስ ስለሚያደርግ ተጠቀምኩ።
Okay, thank you, Mr. Asagid. Okay, do you have a question, Dr. Mulek?
Let him continue.
Yeah, actually he finished. It is better to...
Yeah, I finished the internal.
Yeah. It is better to handle... I don't know how much you are satisfied with response, but we will handle in its grading or result sections. Now, let me move to Dr. Yalisho as internal examiner to raise your comment and questions. I already give you time 10 minutes with extension of 5 minutes. So it's time to Dr. Yalisho. If you are speaking, we are not hearing you. Maybe your mic.
Is my screen visible to all of you?
Yeah, it's visible. Continue.
Okay. Good. So also, I want to thank Wolaita Sodo University for giving us this chance to examine the MSc students, and also I want to thank Mr. Asagid for his nice presentation. So I don't like to focus on the documents write-up issues. Just I want to see the major technical parts which has to be rectified by the candidate. So starting from the title. The title says voltage profile improvement and reactive power compensation. Reactive power compensation for power loss minimization of distribution network using FCTCR for some, for Wolaita Sodo substation outgoing feeders. So, Asagid. Hello? Yeah, from your power system analysis, it is known that this voltage profile of a given system has a close relation with the reactive power compensation.
Yes.
Is that no?
Yes.
If you are compensating the distribution system, then definitely the voltage profile of the system will be improved, and also loss of the system will be minimized.
Yes.
So there is somewhat cause and effect relationship between reactive power compensation and the voltage profile. So I don't seeing that this title is sounding logical for me. Voltage profile improvement can be, you see, the result of reactive power compensation. So it can be rephrased like reactive power compensation for voltage profile improvement and loss minimization. That's enough. And you can take the FCTCR to the methodology part. Somewhere you can write the FCTCR TCR in your scope part also you can consider, because this one is it seems almost paragraph. So the major change you have to make is the reactive power compensation for voltage profile and loss minimization using FCR TCR, or you can leave the last part FC TCR. But the major change you have to make to the title is what as I'm telling you now, okay? Because voltage profile has a strong relationship with the reactive compensation, and also loss has loss minimization can be taken as the result of reactive power compensation. Okay, so why you have chosen the FCTCR? You see, this FCTCR is facts technology, and it is known that FCTCR can both consume and it can inject the reactive power to the system.
Yes.
So most important question for you, is there any capacitive load in the Wolaita Sodo distribution system? This FC TCR can be used in transmission line. It's facts technology, and this facts technology, in most of the time, they are used in long transmission lines, because long transmission lines sometimes they can inject reactive power to the system, and sometimes they can absorb the reactive power depending upon their loading profile. So, but I don't see the need to integrate FCTCR in distribution system, because in distribution system the most pronounced problem is absorption of reactive power, not injection, because the distribution lines are short lines. Their maximum length can go up to 20 to 30 kilometers. You see, this is short line. So for short line, we don't consider the injection of reactive power by the network. So, looking at your acronyms and abbreviations, okay? Yeah, it was put in a nice manner, but AASR, the first acronym you have defined, all aluminum silicon reinforced. Is that right?
No, aluminum, sorry, it's aluminum.
All aluminum?
Silicon reinforced. Silicon reinforced.
Silicon reinforced. Is that right? I am asking you. Is silicon material used in transmission lines or distribution lines? So you have to change. You have to use the right word there, okay?
Yes.
The right word.
Yes.
And coming to your abstract part, which is the most important part of your research work, where somebody wants to see the major findings and the results from your research work, but you put some sentences which have no relation with the abstracts. For instance, furthermore, the optimization of facts, devices placement, and the multi-objective optimization techniques are recommended. It's not a place for putting recommendation, you see?
Okay.
Abstract is not a place for putting recommendation. This is a place where most research findings and quantitative figures are placed, okay?
Okay, correct it, Doctor.
So you just try to put here the size of the FCTCR, which is 20.77 MBAR. That looks fine for me. Okay, like that. All other information, for instance, the voltage profile improvements. Your system is that operating at over voltage condition from 1.4412 per unit to 0. So if that is really your result, I don't think or I don't agree with that, because you are working in distribution systems directly behind the distribution substation. So 1.4412 per unit is a case of over voltage. So you see the result of this reactive compensation is, you see, to upgrade the poor load voltage profiles and also to minimize the losses. If that is the objective, you see, your findings are contrary with the objective of your thesis. So my important question also, you can respond, okay? Because of time pressure, you can respond. What is the existing voltage control or regulation strategy implemented in Wolaita Sodo substation?
Capacitor banks. They use capacitor banks. They use capacitor banks for their reactive influence or power.
Okay, they use capacitor banks.
Yes.
What is its rating? You haven't mentioned anything about that. You haven't mentioned anything. You see, if there is something related with the reactive compensation, you have to see whether that is, you see, reliably operating or not. Okay, whether it is effective or not. How about the on-load tap changing mechanism? On-load tap changing mechanism of the distribution or the power transformer there. You see, the purpose of using on-load tap changing mechanism is to regulate the voltage during the light loading and heavy loading times. You didn't say anything about the existing technology which are in use in your area of study. I found this as also a major gap for your research work.
Improve it. Improve it, Doctor. Final.
And
sorry, Dr. Yalisho, you used 10 minutes. I will 5 minutes extra.
Just give me one more minute.
You will borrow from my time. Already my points are raised by Dr. Mulana. Overall, you will have 10 minutes, no problem.
Okay. May I stop or may I just continue for 1 minute?
Yeah, continue. I add 10 minutes.
Most important, and it may be the last for the candidate. Your proposed technology, that is FCTCR, is going to be placed in the second node, which is very near to the substation. Is that not?
Yes.
Do you think that is the optimal place? Placing the FCTCR as the second node. Do you think that is the optimal place for reactive compensation? You have to respond to these questions. Okay, thank you very much, Mr. Chairperson.
Okay, thank you. Okay, go through the questions that raised by Dr. Yalisho. Mr. Asagid.
Okay, thank you, Doctor, to giving a comment, a construct comment to on my thesis. So I respond some of them, and I take as a comment to correct final thesis. So the question is authorized by Dr. Yelisho is the optimum place to replace FCTR? Yes. So yes, because on search or on thesis, so we identify or we select the weak bus by so many የተለያዩ እንትኖችን በመጠቀም ቅድም በለየዋቸው እንትን ላይ አሁን ልዊክ የሆነ ባሱን በለየውት ላይ ኤፍሲቲአርን ኦፕቲማል በሆነ ቦታ ላይ ወይም በዛ በሰብስቴሽኑ አውትጎይንግ ፊደሩ ላይ ቢገናኝ ምንም ችግር እንደሌለ እንትን ብሏል። ትክክለኛ አውትፑት ይሰጣል። ምክንያቱም ዊክ ባስ ስለሆነ የሱ ስራው ዊክ ባሱን በሬክቲቭ ፓወሩን ኮምፖዚት በማድረግ ነው። ሬክቲቭ ፓወሩን ኮምፖዚት ሲደረግ ነው ቮልቴጁ ኢምፕሩቭ እየሆነ የሚመጣውና ሰው ባሱ ዊክ በሆነ ቦታ ላይ ወይም እኛ በሪሰርቹ ላይ ዊክ ባሱ ላይ ብንገናኝ ፋክት ቮይስ ኦፍ ብናገናኘው ኤፍሲቲዛ ብናገናኘው አውትፑቱን ይሰጣል። አዎ
Yeah. Okay. Thank you, Mr. President. I have some issue regarding your paper. From your title, voltage profile improvement and reactive power compensation for power loss minimization. So these all things are done by using FC, thyristor controlled rectifier. Do you think that this FC, that means fixed capacitor bank in another word, can address the issue of voltage profile as well as the reactive power compensation as well as power loss? That's my concern. And also you have to try to shorten, and by itself individuals have can be a thesis. Rather, in my point, voltage profile improvement is done rather than FC using dynamic voltage restorer. DVR is the most appropriate in order to regulate or improve the voltage profile. So if you have any reflection regarding to using FC in order to address these all things together, this is my one concern. And also my points, my own points Dr. Muluna raised regarding to the firing angle. Simply you are stating by the procedure over all the techniques orally and in written form, but we didn't see in your document the detailed modeling, the design, and the timing as well, the angle. Everything are not mentioned properly, rather than you are speaking the steps, the procedures, how it is functioning. But not that the right way. You have to address in modeling, in designing, as well as in determining the settling values. So we didn't see such kinds. From your acronyms, facts, the way you elaborate is wrong. Flexible AC transmission system, not distribution system. You say it's distribution. So you have to just to bring it into your research area, you associate to distribution, but it's not right, it's not correct. When it comes to abstract part, you simply stated in one line, rather you have to sectionalize into different paragraphs that contains the gentle introductory aspect as well as the methodology and the algorithm and the software you used. You have to describe in the other paragraph of the methodology, and finally you have to bring a result or summary. That's a complete work of your paper. So make it modification by sectionalizing into these paragraphs. That's what I'm going to say. Finally, I doubt regarding to your font size and line spacing aspect, and also the editorial, the grammatical error, all things you have to go through again based on the university guideline paper. So if you have any reflection, something that I wrote, I will give you 2 minutes, unless we will conclude here.
Okay. Yeah. Arise FSTTR. So, based on the title says voltage improvement reactive for composition for power loss by using FSTTRs. So this all voltage and voltage reactive power voltage and power loss are already the directly related. So we improve by using this reactive power only. This all that are mentioned above are already improved. That means if the reactive power composite or reactive power are raised or updated, then the remain or the voltage either the power loss can be already improved or rise the level. So by the means of this, I use the fact device or FSTRs that is simply update the or composite reactive power. So we operate or we composite reactive powers, the all voltage profile and power loss also a composite or make change or updates. So this all are my comment I can correct on my document. So thank you.
Okay, thank you, Mr. Asagid. And before we leave this session, Dr. Mruna, if you have a plagiarism index that you extracted from the software, please share us. I forgot asking this before. If you have, let us share.
Oh, okay.
I think
actually, based on yesterday's discussion, actually I paused and we'll discuss later.
Right. Okay. So we are running out of time and it is lunch time. Maybe we are left with 2 candidates to make an evaluation. So it is better to come back in the afternoon section. What are your comments, Dr. Mulana?
Actually, after afternoon session, our international conference is closing.
Okay.
So shall we just proceed with one and maybe the one which is left maybe other time or during the evening? I don't know.
During which time you are free?
Maybe I can return back maybe after 4 o'clock or something like that.
4 o'clock is enough to make evaluation post.
Well, yeah. So maybe.
Okay, Siraj.
Yes.
I think from my side, it is better to give the result of our evaluation for these 2 students, and the remaining 2 students might be evaluated, if possible, around 9:30 local time. We can start. I don't know the schedule of Dr. Mulune, as what he is saying. There is a conference, an international conference is going on in our campus. So maybe can you get enough time for evaluating these 2 students?
I think it is better to evaluate together, or for discussion purpose, it is more better to make it together. For in one.
Yeah.
Rather than making 2 separately, after finishing all the presentation with common ground, better to make a discussion.
Actually, better to finish all and.
For the discussion, it is important. It is more important by looking all their presentations in similar manner. We can wait them. I think Dr. Mule, if possible, at 9:30 we'll wait you. Even if it goes to evening, no problem from our side.
Because for me, it's okay to come after 4:00 after the closing ceremony.
Okay.
Like
So,
I cannot come in the middle, or we don't know exactly. Maybe I